Edward Jenner is considered the founder of vaccinology. In 1796, after he inoculated a 13-year-old boy with vaccinia virus cowpox and demonstrated immunity to smallpox. In 1798, the first smallpox vaccine was developed. Origin of vaccines. Smallpox first disease people tried to prevent by purposely inoculating themselves with other infections. Inoculation started in India or China before 200 BC. Physicians immunized patients by picking off pieces from drying pustules of a person, inserting the powder into the person's nose. In 1718, Lady Mary Montagu reported that the Turks have a habit of deliberately inoculating themselves with fluid taken from mild cases of smallpox. Lady Montagu inoculated her own children in this manner. In 1796, Edward Jenner observed that milkmaids get infected with cowpox, a mild relatively of the deadly smallpox virus. Jenner took infectious fluid from hand of milkmaid Sarah Nelmes, inserted this fluid by scratching or injecting into the arm of a healthy local 8-year-old boy, James Phibb. Phibb then showed symptoms of cowpox infection and recovered after 48 days. Jenner injected some smallpox-infected matter into Phibb's didn't later show signs of smallpox infection. Germs are all around us, both in our environment and in our bodies. Vaccination is a method of giving antigen to stimulate the immune response through active immunization. A vaccine is an immunobiological substance designed to produce specific protection against a given disease, viable or non-viable pathogens, or purified product. A vaccine is antigenic but not pathogenic. Types of vaccine: live vaccine, attenuated live vaccine, inactivated killed vaccine, surface antigen recombinant vaccine, toxoid, polysaccharide and peptide cellular fraction vaccine, live attenuated vaccine. Virulent pathogenic organisms are treated to become attenuated, retain their immunogenicity. Attenuated microbes reproduce in the recipient more robust and long-lasting immune response. Should not be administered to persons with suppressed immune response. Risk of reverting to an active pathogen: Sabine poliovirus, measles, mumps, rubella, Barcella. Inactivated killed vaccine: organisms are killed, inactivated by heat or chemical, remain antigenic, usually safe but less effective. No risk of vaccine-associated infection, more heat stable, only absolute contraindication: severe local or general reaction to previous dose. Microbial extract: instead of whole organism, it's composed of antigen globules. Extract from the pathogen or prepared by recombinant DNA technique. Efficacy of this vaccine varies. Toxoid: prepared by detoxifying the exotoxin of some bacteria, rendering them antigenic but not pathogenic. Adjuvant: aluminum precipitation is used to increase the potency of the vaccine. When a person is susceptible and they encounter a harmful organism, it can lead to disease and death. The body has many ways of defending itself against pathogen disease-causing organisms: skin, mucus, and cilia, microscopic hairs that move debris away from lungs, all work as a physical barrier to prevent the pathogen from entering the body in the first place. When a pathogen does infect the body, our body's defense, called the immune system, are triggered and the pathogen is attacked and destroyed or overcome. The body natural response to a pathogen is a bacterium, virus, parasite, or fungus that can cause disease within the body. Each pathogen is made up of several subparts, usually unique to that specific pathogen and the disease it causes. The subpart of the pathogen that cause the formation of antibodies is called an antigen. The antibodies produced in response to the pathogen antigen are an important part of the immune system. You can consider antibodies as the soldiers in your body defense system. Each antibody or soldier in our system is trained to recognize one specific antigen. We have thousands of different antibodies in our bodies. When the human body is exposed to an antigen for the first time, it takes time for the immune system to respond and produce antibodies specific to that antigen. Once the antigen-specific antibodies are produced, they work with the rest of the immune system to destroy the pathogen and stop the disease. Antibodies to one pathogen generally don't protect against another pathogen, except when two pathogens are very similar to each other, like cousins. Once the body produces antibodies in its primary response to an antigen, it also creates antibody-producing memory cells, which remain alive when after the pathogen is defeated by the antibodies. If the body is exposed to the same pathogen more than once, the antibody response is much faster and more effective than the first time around because the memory cells are ready to pump out antibodies against that antigen. This means that if the person is exposed to the dangerous pathogen in the future, the immune system will be able to respond immediately, protecting against disease. This is existing pathogen and the existing antibody. It differ. This is the chickenpox. This is the measles, flu. Different pathogen have different shape, so different antibodies detected. How vaccine help? Vaccine contain weakened or inactive parts of the particular organism antigen that trigger an immune response within the body. Newer vaccine contain the blueprint for producing antigen rather than the antigen itself. Regardless of whether the vaccine is made up of antigen itself or the blueprint, or so that the body will produce the antigen, this weakened version will not cause a disease in the person receiving the vaccine, but it will prompt their immune system to respond much as it would have on its first reaction to the actual pathogen. The vaccine, and this is the new antibody. Vaccine is a teeny weakened, non-dangerous fragment of the organism and includes parts of the antigen. It's enough that our body can learn to build the specific antibody. Then in the body encounter the real antigen later as part of the real organism. It already know how to defeat it. Some vaccines require multiple doses, given weeks or months apart. This is sometimes needed to allow for the production of long-lived antibodies and develop memory cells. In this way, the body is trained to fight the specific disease-causing organism, build up memory of the pathogen so as to rapidly fight it if and when exposed in the future. In the early 19th century, polio was a worldwide disease, paralyzing hundreds of thousands of people every year. By 50s, two effective vaccines against the disease had been developed, but vaccination in some parts of the world was still not common enough to stop the spread of polio, particularly in Africa. In the 1980s, a united world effort to eradicate polio from planet began over many years and several decades. Polio vaccination using routine immunization visit and mass vaccination campaign has taken place in all countries. Millions of people, most children, have been vaccinated, and in August 2020, the African continent was certified wild poliovirus free, joining all other parts of the world except Pakistan and Afghanistan, where polio has not yet been eradicated. The success of an inactivated killed polio vaccine developed by Jonas Salk was announced in 1955. Another attenuated live oral polio vaccine was developed by Albert Sabin and came into commercial use in 1961. And this is a schedule, international schedule for the vaccination of children from 2 months to 14, 16 years.